example, can you see from this? This will, no, not from this one. This one, this is the partial double bond character, right?
Yes, sir.
So this is one of the reason. There are other reasons as well, because electron density is present in the benzene ring, which will repel the oncoming nucleophile. So nucleophile is electron density high. The carbon, the benzene also have electron density within its ring, so it will repel. Okay, and the second point is phenyl carbocation is very unstable. Can anybody tell why phenyl carbocation is very unstable? Why? I've already told you the reason. Yeah.
Because it has a partial double bond.
No, the bond has already been broken, and we are taking the extreme case that positive charge is present on this phenyl,
Okay.
so in this benzene. So, but positive, why positive charge is very unstable here? Siddhika, any guess? Your answer could be wrong, but no problem. So let's not waste our time.
First, there is repulsion between the partial negative and positive.
Repulsion, partial positive and negative. Repulsion between this and which one?
The partial negative bond.
Where is negative charge here? The benzene ring charge. The
Yes, sir.
charge in the, okay. Uh, so that is negative. So negative and positive will love each other, na? Why they will repel each other? They will attract each other. So that should be means stable, right? If you are saying that this is having negative, yes, that is correct. In a certain way, electron density is higher, yes, but positive loves negative, so it should be stable. But why it is unstable? Let's see. We have benzene ring present here, okay, and we have positive here. This is the original one. So this is sp2 sp2 carbon electronegativity is very high. I have already told you. I think yes I have. sp electronegativity is higher than sp2 than sp3. Okay, its electronegativity is very high. Electronegative, the entity which whose electronegativity is very high, they want electron on it, right? Not positive charge, right? They love negative charge on themselves, not positive charge. Is this good?
Yes, sir.
So that is why this is sp2 carbon. sp2 carbon would not like to have positive charge. It is electronegative. Okay, so electronegative atoms do not like positive charge over it. So here is positive charge. You are, you know, means like forcefully you have put positive charge on it. So this is bad for its health. That is why it is unstable. Okay.
Okay, sir.
Uh, there is one more statement you can understand. As S percentage S increases, electronegativity increases. This is one of the statement you may have heard in this what chemical bonding in class 11th. So here S has 50% character. Here S has like 33%, and here S is like 25%. So percentage S increases, electronegativity increases, and this is very much common to you people. Like electronegativity, electronegative atoms like to have negative charge on it, not positive charge. And you are pushing here, pushing this carbon to have positive charge on it. So this is very unstable. Understood?
Yes, sir.
Siddhika, you you understand that this is sp3 carbons, this is sp2 carbons, and this is sp carbons. So yeah, yeah, you know this.
Yes, sir.
So this carbon is double bonded, so double bonded carbon are sp2. sp2 is there, electronegativity is high, positive charge is unstable. Okay.
Okay, sir. Yes, sir.
Mm. I'm giving nearly every explanation, means for every statement, right? So that it would be quite good for you for understanding, and you can remember also if you relate it with other topics and from class 11th also. So but we are going to study what haloarenes shows nucleophilic substitution reaction on two conditions. There are special conditions special conditions in which haloarenes will show SN reaction. These points which we are studying, this is not possible in normal conditions. The special conditions which we are going to study here is, let's see, at high temperature, okay, and high pressure. Okay, at high temperature, high pressure. Uh, NCRT uses this word drastic condition. Drastic condition. Obviously, when you increase temperature and pressure, the molecules have very high energy and the chances of collision is very high. That is why nucleophilic substitution reaction can happen. There are very drastic condition. We will see what the drastic conditions are in examples. And the second condition is electron withdrawing group is placed at ortho or para position. Okay, electron withdrawing group is placed at ortho and para position. These are the two reasons. Let's see the example. What are the drastic conditions here? So for example, we have chlorine here, okay, and the benzene ring, and we have aqueous NOH present as a reagent, and the high temperature 623 Kelvin and high pressure 300 atm. Such a high pressure, on such a high pressure and high temperature, what we see here is this OH will attack on this and chlorine will get removed, and we will have O minus, or you can say OH, or you can say O minus Na, because this is in in acidic medium, that is why. Or you can substitute the Na with OH. Got it?
Yes, sir.
Let's see the other cases. Here chlorine is you know attached with NO2, so it is electron withdrawing group. uh, Siddhika and Yahya, you understand electron withdrawing group concept? Huh? Electron withdrawing group. Yahya?
Yes, sir.
Good, 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 good. So see, in this case, we are taking aqueous NOH. Uh, the temperature will be at 443. Kelvin. Okay, and we are also using H plus in the acidic medium. This is happening. So finally, we will be having OH. Since electron withdrawing group promotes nucleophilic substitution reaction, so we will have OH. It has been replaced, and NO2 was already present there. So the temperature has been decreased a bit. Okay, because of this electron withdrawing effect of NO2. This is another case where NO2 is also present at ortho position and para position as well, and we have aqueous NaOH, but the temperature has can be decreased because we have two promoters here, two electron withdrawing groups present here, and we have H plus here. So finally, this will the product NO2 NO2. The Cl has been replaced by OH. And the third case, let's in the third case, what we will see, we will be adding two NO2 group at ortho position and one at para, and we can see that in lukewarm water only, not at high temperature, at a warm condition, what will happen? This will nucleophilic substitution reaction will occur, and chlorine will be removed, and finally we will be having this. Okay, so the in the all these three reactions, what we have learned in when we have no electron withdrawing group, we have to use very drastic conditions: 623 Kelvin, 300 atm pressure. When we have added one NO2, then the temperature has been little lowered. When we have two NO2, it has been more lowered, and that is why we see that electron withdrawing groups promotes this reaction, nucleophilic substitution reaction. Understood, everybody?
Yes, sir.
Huh. So what is happening actually? Let me draw it for you. This is the chlorine, and we have this benzene here, and OH minus from NaOH, it is attacking on this point. Okay, and when this will be attacking this point, what will happen? OH and chlorine will be present at this space, and this will attack on this, and this pi bond will shift and make a negative charge here. Okay, and the negative charge will again shift the resonating structure which we are drawing here, shift, and the positive negative charge will come here this side. So finally the structure will be this. Okay, so when electron withdrawing group is present at this position or this position, can you see negative charge is present in which positions? Ortho positions
And para.
and para position, right? So
Yes.
the when electron withdrawing group is present there, means it withdraws electron from here, so that will increases the stability. That is why it is possible for it is quite understandable that electron withdrawing group are promoting this reaction, right? And
Yes,
in
sir.
similar way, this will attack here, and chlorine will leave, and finally the product will be formed. Just tell me, have you understood this?
Yes, sir.
Siddhika? Please note this down. Written the two steps.
Yes, sir. Done, sir.
Siddhika, please respond. Okay. So let me see. There is a question here. So please, give it a try. This question selected from NCERT. You have 1 minute more left. Coming in a minute. The reaction, can you recognize the reactions?
Yes, sir. First one is reaction with metal, and the second one is also like to form A, we have to use the reaction with metal, and to form C, we have to use the reaction with metal theory,
And third
and
one, which reaction
third
is
one, Wood's reaction is taking place. Okay.
so
Wood's reaction, and then again we have
in the
a
reaction.
reaction with metal.
So I think hopefully you will get the right answers. Please write.
So I'm stuck. What will happen when A reacts with H2O?
I will do it. Don't worry.
Okay, sir.
However, it is maybe it is written in your just you can check out.
Okay, sir. Sir, is in the third one, is that R dash by X is dash R dash?
You have to find R dash also.
Oh, okay, sir.
Siddhika, have you tried to questions? Just one opening head. Please, we have this. Yeah. On the next paper, this topic will not be form the types of guides and others. So,
Sir, I got this one as benzene ring. One is MGBR and the other one connected to the first is OH. Sure.
so why it has been some negative charge, partial negative charge, but it has been attached with magnesium. So is the metal. What this has positive charge, this has negative charge. To attack on this H, take this H from HOH. In this example also, let's study this. RX, RMGX has been attacking on HOH. What R will attack on H. Shishika, yes or no? Let's see the second question. Yeah, same thing is happening. What will happen in the presence of D, like H2O, isotope of hydrogen? This R will attack on D. And what is seen here is understood that can be yeah.
Yes, sir.
Can't hear me?
Yes, sir, your voice is very far away.
Yeah, I'm so sorry. So till where I have explained? What was the last statement you have heard?
That R will attach to D.
R has been attached to D. Okay, because R has been attacked has attacked on D2O. One of the like the structure which I can draw here is like this. So obviously it will attack on this. D. Okay, and RD will form.
Yes.
Understood, everyone?
Yes, sir. And sir, another product will be formed with MgDO, right?
That is not important. Na? I have told you earlier. Maybe I have told
I
that
I wrote
substrate
it.
is ah. So this will be forming as this OH MgBr. Okay.
Okay, sir.
This is not at all important for you. That is why I am not even writing this. Right. Uh, don't burden yourself with the byproducts. Just remember the main concept. Okay.
Okay, sir.
Like for example, uh, with example you will be clearly understanding. Like if we have this br is attached here. Okay, so then what we will getting, we will be getting like this mgbr. Okay, this will be having negative charge on it, so it will attack on d2 and it will be getting like this. Understood?
Yes, sir.
Siddhikar. So let's try the other question. In this question we are having this. Okay, I'm writing the methyl thing. Okay, which has been formed from Na plus Na ether. Okay, this is a
Yes, sir.
Woods reaction. Siddhika, you may remember Woods reaction. So, it is like this. So we have to understand it like this should have happened because of this carbon has been made a bond with this carbon. Okay, so we'll be having a structure like this. Okay, and it should be attached like with this halogen. When this halogen will go, okay, so what will happen, I'm just writing the intermediate for you to understand it better. Sorry. So what will happen, this two will make bond and this will form. Okay, are you getting this?
Yes, sir.
So this is r dash x. Okay, and when we do this mg thing on it, mg dry ether, obviously we know that this will form. Okay, got it? And
Yes, sir.
when we react with mgh2o, this will be replaced with h, means mgx will be gone, h, right?
Yes, sir.
Understood, yeah,
Yes,
Siddhika?
sir.
uh, if you have doubt in any step, just let me know. Okay, good. So there are certain concepts which came here, reaction with metal, and especially this Woods reaction and with Grignard reagent. Both have to. Acha, note it down. Kindly note it down. So,
Yes, sir.
डन जी। सिद्धिका, हेलो, डन। यहिया।
Yes, sir.
So one small topic which was in this chapter is chirality. Chirality. Have you heard about this term, chiral carbon chirality in enantiomers? Hmm?
No, sir.
Optically
Yes,
isomer, optical isomers, optically active, inactive.
I think sir taught us about optical isomers, but
Okay,
that's
okay.
it.
Siddhika, any comments, Siddhika? So we are going to focus on carbon. Obviously, we are doing organic chemistry. So chiral carbon, carbon, when carbon is attached to four different atoms or groups. Atoms or group. When carbon is attached to four different atoms or group, the carbon will be known as chiral carbon. Okay. Let's see with example. Like for example, carbon is bonded with bromine, iodine, fluorine, and chlorine. So this will be a chiral carbon. Okay. Uh, we denote it like this: star mark on the carbon. Okay. When we see carbon like this, hydrogen, chlorine, carbon, and chlorine, hydrogen. So we what we are seeing here is we have two hydrogen present on this hydrogen. So this is not a chiral carbon, right? Because two of the atoms are same. Okay, are you getting my point?
Yes, sir.
Ah. Dika, just let me know when you will having you are getting some doubt. Just let me know. Let's see with the other examples as well. So we have one chlorine present here. Okay, in this example, what we see, we have one methyl group here also, one ethyl group, one chlorine, and obviously we know that one hydrogen is present here, right?
Yes, sir.
Because carbon has to satisfy four valency. So this carbon is chiral carbon. The rest carbon, we see three hydrogen present here. So this is not chiral carbon. In this, two hydrogen is present there, right? So this is also not chiral carbon. There is three hydrogen present here. So this is also not chiral carbon. Understood?
Yes, sir.
Uh, like for example, CH4. This is also not chiral. Like for example, chloroform, CHCl3. This is also not chiral carbon. Sorry, CCl4 is. So this is also not chiral carbon, right?
Yes, sir.
Uh, let's draw one structure and please tell me if this is a chiral carbon or not. Please let me know how many chiral carbons you can find in this structure.
One, sir.
Siddhika, how many chiral carbon can you see? Okay, so let's see. This is not a chiral carbon. This let's see this carbon. So this carbon is attached with this carbon, and one hydrogen in this methyl group. So this carbon is different from this carbon, right? Because this
Yes,
carbon
sir.
is attached with chlorine. This carbon is attached with two hydrogen. So this carbon is chiral carbon. Okay. Let's see with this carbon. This carbon is attached with one hydrogen, one ethyl group, this group, and this side. So uh, if we are seeing this side is this side, and this side is different for this
Yes.
carbon. So that
Yes,
is
sir.
why this this is also a chiral carbon. Okay. This is a little complex, but I hope you can bear with this example. Let's see
Yes,
this
sir.
this carbon is attached with one chlorine, one hydrogen, this side and this side. So this carbon is different. This carbon is also chiral carbon. This carbon is attached with two hydrogens. So this is not chiral. This is also not chiral. This is also not chiral. This is not chiral. This is also not chiral. So we have three chiral carbons present
Three.
here. Understood?
Yes, sir.
हाँ. So please do this question. Acha, I have to let you know the wedge and dash representation. Do you know what is wedge and dash representation?
One is bonded and the other one is not bonded.
See,
Partially
wedge and dash.
bonded.
No, 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 no. There is no partially bonded thing here. The carbon which is present at the darker lines. The darker lines represent uh, in front of the plane. Okay. Uh,
Oh,
let me, you know, can you see me?
yes, sir.
Huh. So, for example, this is uh, a plane, okay, and we have a structure here. So, in the first structure, please see the first structure. We have hydrogen and OH in with a single normal bonds. Okay, so they are into the plane. Okay, the hydrogen is
Yes, sir.
present here, OH is present here. The bromine is darker shade, so bromine is present in this side. Okay, and CH3 which is dashed is present in this side.
Below. Backside.
Okay, so this hydrogen and OH are in plane, Br is out of the plane, and CH3 is into the plane. Okay,
Yes, sir.
understood, Siddhika? So please count the chiral carbons. Identify the chiral. The one which is not chiral is called achiral. Okay, and the one which has at least one chiral carbon are chiral molecules. Okay. See, in this one, it has already told that in class 11th, you should have known wedge and dash representation. But no problem, because you have very chiral molecules are those molecules which have at least one chiral uh, carbon or any atom, chiral atom. We are only concerned with carbon here. And if the molecule has no chiral carbon, so that will be a achiral molecule. Siddhika, can you comment on the first one? Uh, this first one. Is it chiral or is it chiral, or they are both chiral or both unchiral? No, sorry, achiral in this structure. Mm. Done the second one. Have you done?
Yes, sir.
Uh,
Yes, sir.
Please tell me the answer. What do you want?
Sir,
Both chiral or
first one is chiral because
okay,
around
okay. And the
star,
second one? I will
it's
tell
not
the
chiral.
reason.
It's not chiral.
Both are not chiral.
No, first one is chiral and second one is
Okay,
not chiral.
okay. So Deka, third one. Solve the third one. Done. Siddiqa. Check. Now let's see. This carbon is having this this carbon is having one OH, and means every group is different for it. So this one is chiral. Okay. And in this one, we have in on this carbon we have one hydrogen, one methyl, and two bromine present here. So this will be achiral. It would be achiral. Uh, Understood? से देखा यही है.
Yes, sir.
से देखा. The thing which we have to see here, not wedge and dash. This is for representation only. We have to see the carbon should not be having same group on it. Okay. Now the next one, in this carbon is having this group, this group, this group, and this group. It's quite clear that this is chiral. Okay. And this one, in this carbon we have HOH, and this group is similar for both. It means you can see CH2 CH3 here, CH2 CH3 here. So this is not chiral, achiral. This one, uh, this one is, this carbon is having bromine, but it has two hydrogen. So this one is wrong. This carbon is having, see, this one is chiral. Why? Because it has one CH3, one H, two C, this group, and one bromine. So this one is chiral. Understood?
Yes, sir.
Uh, Good. Please solve this question.
Sure, sir. I answered in the chat.
हाँ. You two people are doing good. Just the problem you may face, since you are not doing revision and not doing homework. So this will be, you are good in class, but not doing homework will not help you in longer term, right? And if you do homework also, na, and you are present in class, you are doing this will also not work in longer time. Why? Because it needs revision. It is very, yes, I know that this is very, build up pressure on you, but the reality is this thing only, that without revision everybody forgets. Okay. When it is not, limited to, it is very common thing. People forget. See, so this carbon is not chiral. This carbon is not chiral. Let's check for other carbons. So this carbon is chiral, right? Because it has hydrogen, OH, CH3, and the bigger group. Okay. This carbon is also not chiral because two hydrogen is present there. Let's check for this carbon. So this carbon is having this H, this big group, and this group. Both groups are different because this group has alcohol in it. This group has ethyl in it. So this is different, and H and Br. So this one is also chiral. Let's check for this carbon. This carbon has one hydrogen, one methyl, one ethyl, and a bigger group which is totally different from other groups. So this one is also chiral. Let's check for this carbon. This carbon, you have to understand that the structure is like this. So this carbon has two hydrogen, not chiral. This three hydrogen, not chiral. So this one. So which one you missed?
I missed the CH one, sir.
Last one or middle
Last
one?
one. Last one. Last one.
Okay, okay. So understood?
Yes, sir.
Satyaka? Uh, so this is a chiral compound and having uh, uh, three. Please solve this question. Siddhika. So let's see. So in this four structure, let's see the first one. The first one has one hydrogen, and all three are different. So obviously this is chiral. Sorry. In this one, let's check. This is not chiral. This is chiral is defined for only sp3 carbons. So this is not sp3 carbon. We will leaving this carbon. This carbon has one hydrogen. This group, this group, this group. All groups are different. Okay. So this is also chiral molecule. This is carbocation. This is not. This is sp2 hybridized. So this is not chiral. Let's check out for this. These two are similar or no. So this is not chiral. So only one and two are chiral. So this is the right answer. Good. So understood, Hannah?
Yes, sir.
You both have solved correctly this, uh, triple E question. So let's move on to the next topic, the subtopic of it, optically active. What are optically active compounds? So the compounds, please note with me, note this thing with me. The compound which rotate the plane polarized light is PPL, plane polarized light, in clockwise or anti-clockwise direction are called as optically active compounds. You have done this right. Done writing? Shall I explain?
Yes, sir. Thanks.
Hmm. So see, what happens is we have light, and light is shown in this way. Why? Because it is electromagnetic radiation, and the electric and magnetic field are constantly oscillating this in this way. We have and the Nicol prism here, and why we are using Nicol prism here, so that this oscillation of this electromagnetic radiation is fixed when in a single direction. That is why it is known as plane polarized light. Okay, why we have used this, so that we can check that the oscillation direction of this EM waves has been changed in a direction or not. So this has been changed. Okay, and we check it by polarimeter, how much it has been changed. Okay, so we have the compound here. The compound is present in this. Okay, any organic compound which is present, the solution is present in this. Okay, beaker, and the light is passed through this. Okay, and if the solution is optically active, okay, by the definition, this will rotate the plane polarizer. The plane, this is the plane, this is the PPL. What has been selected? This is the PPL which has been rotated. Okay, as you can see. So this is a optically active compound. If it has the ability to rotate the plane polarized right, it will be known as optically active compound. Got it?
Yes, sir.
Huh. And what does polarimeter do? As I have said, it measures the angle, measures the angle by which PPL, plane polarized light, has been rotated. Okay. अब rotation of PPL can takes in two form, clockwise and anti-clockwise. Please note this down. Done.
Yes, sir. Above part after the
हाँ
reaction.
हाँ, above part is important. Now I'm going to explain and then let you know what is it. एक second. हाँ. So rotation of PPL can takes place. Rotation of PPL takes place in clockwise and anti-clockwise direction, obviously. So when it will be moving in clockwise direction, then we will say that D form. Okay. And when it moves anti-clockwise direction, we will say L form. Uh, like when you buy medicine, na, some of the medicine is written like, you know, falana D, falana L, है ना? So you can check it, the syrups in your home. So D form means dextro dextro rotatory dextro rotatory. It is represented by plus, and the L form is, the full form is levo rotatory, represented by minus. Okay. Hello.
Yes, sir.
Huh. No, I thought means my connection is little. Hmm. So so what are these? The compound, the definition where I'm writing it, the compound with same same molecular formula and structure formula. Okay. But only differs in the direction of, in the direction. Please note it down, of rotation of PPL are called as, very important, optical isomers. So the PPL can be, the plane polarized light can be rotated in positive, clockwise also, anti-clockwise also. So the compounds which have same, exactly same molecular formula and a structure formula also, the structure is also same. Okay. but the direction they are rotating the plane polarized light in different direction. So such isomers are known as optical isomers. They have the same structure formula. Structure is also same for them. Okay, done copying.
Yes, sir. Yes, sir.
Okay, so please solve this question. The question, let me give you a hint. uh, on hydrogenation means you have to just remove the pi bond. Okay, remove pi bond in the whole, the all three four options. Okay, and just let me know uh, when you see chiral carbon, you will just directly comment if chirality presents. If chirality presents, they will be, you know optically active compounds. Sorry, optically active.
But
If
sir,
chiral,
here double bond is present no, everywhere.
so that's why na, the question says the compound that on hydrogen produces optically active. So remove the double bond. Okay,
Oh,
so if we remove the double bond, obviously we will get, I hope you understand. 1 2 3 4 5 6, 1 2 3 4 5 6 8 3 5 only, and we have bromine here. Okay, this is the structure.
and H.
Please solve this question. So see, in this one, the first one, what we will see, we have chiral carbon here, right? You were
Yes, sir.
able to identify chiral carbon.
Yes, sir.
uh, and in this one, this is not chiral.
No, sir,
uh,
because there are
this
the similar.
this is again chiral. Okay, and this one, we have seen bromine here and hydrogen here, two different
Yes,
groups,
sir.
but these two groups are same.
Similar.
So that is why this is not chiral. This is optically inactive. Okay, the same thing is this here also, optically inactive.
Inactive.
Okay, this will be
So, sir,
optically inactive.
A and C are optically active.
Yeah, these two options are correct. However, we have to choose the optically inactive compound. So B and D are correct options.
1 minute, I'll write and note that.
Understood, Siddhika? This is the exact definition of chiral molecule. Yes, that is also true. For solving MCQs, you have to see for chiral carbons, and that is it. You will get the answer. Uh, the molecule which is the molecule which is not superimposable on its mirror image. The molecule which is called chiral molecule. Chiral molecule. So see, we have one carbon present here. Okay, and we have A group here, B group here, C is already in. Let's take X and Y. So we have X here and we take Y here. Y here. Okay, and we are using mirror image of it. So obviously this molecule is chiral, right? We can see four different groups present here. So we will see A exactly in the mirror image. We will see B here. We will see this, and we will see Y here. So this is a quite mirror image. Okay. So let's assume that this is rotating in clockwise direction. So since this is a mirror image of it, so it will rotate the PPL as in anti-clockwise direction. Okay. So it is not, so clockwise, anti-clockwise. These two you have to remember. So these two are optically active isomers, है ना? So they are the mirror image of one other is called as enantiomer. Enantiomers. Okay. The molecular formula is same. The structure is also same, but they are a mirror image of it. So they are rotating the PPL in different direction. So what are enantiomers? Bolo.
So, when we mean we are spinning them in a clockwise to see the like mirror image of each other, spinning them in a clockwise and anti-clockwise.
No, if you spin this molecule, na, then also it will not form exactly this molecule. Okay. Like if you try to rotate it, like you will replace it, like if you move X in Y position, Y in X position, because one is into the plane and one is outside the plane. Then also this will not come this compound. This compound is different.
Yes. But
That is why by the definition of it, by the definition of they are non-superimposable, superimposable mirror images. Okay. About this is about enantiomers. They rotate PPL in opposite direction. So one will be in clockwise, one will be anti-clockwise, and the important thing is with same magnitude. Same magnitude. Like one is rotating is 10 degree, then other will be rotating as minus 10 degree. And this will be the experimental data, so you don't have to worry about it.
Done, sir.
So there is one more thing, racemic mixture. Heard this term, racemic mixture?
No, sir.
uh, so देखा. So the definition of it is racemic mixture is a 50-50 mixture of two isomers, है ना? Two enantiomers I should write. Two enantiomers. Okay. So uh, one will rotate in positive direction, other will be rotating in my negative direction. So what will happen? They will be, in equally cancel out each other. Okay. So PPL, the plane polarized light, means will not rotate. Understood?
Yes, sir.
Hmm. Understood, Siddhika? Because they are cancelling out the rotation of each other. So done copying.
Yes, sir. Done.